Hello friends, let's talk about unsigned data in detail in this video. So in the last video we saw that the range for the unsigned data is from 0 to 2 to the power n minus 1. That means that we can express 0 to 2 to the power n minus 1 numbers in n bit. For example, if we have 4-bit data, we can express 0 to 15 in 4-bit. But suppose we have this number 17, so there will be overflow because we cannot represent 17 in 4-bit. We need 5-bit for same, right? So let's see an example of like addition to talk about the overflow. Suppose we have the input of 4-bit and we add two numbers like 2 plus 3 is equal to 5, but we can store 5 in this 4-bit data range because 5 falls in between 0 to 15. So this will not be a good example for showing the overflow. So we can show overflow only when the sum is greater than 15, right? So we can show like 9 plus 8 17, because 17 we cannot store in between 0 to 15 and we need one extra bit to store the same. But here we are taking the highest number of 4-bit, that is 15 here, and we are adding 15 plus 15, and we are taking 4-bit. So if we add 15 we get 30. We know that we cannot store 30 in 4-bit because we can store from 0 to 15 only. If we test in 5-bit range, so in 5-bit we can store 0 to 31. That means we can store 30 in 5-bit. So if we add two n-bit numbers, we need the result in n plus 1 bit. Here we are adding four like two 4-bit numbers, but we need 5 bits to store the result. Let's see how we like add the binary numbers here. So here 1 plus 1 is 1 0, 1 0. We are taking 0 from here, and then 1 is carry. We are putting this 1 carry here. Now 1 plus 1, 1 0 plus 1, 1 1. So we are taking this 1 here and we are taking this 1 as a carry here. Again 1 plus 1, 1 0 plus 1, 1 1. Similarly here we are taking this 1 and then 1 as carry here. Again 1 plus 1, 1 0 plus 1, 1 1. So we are taking again 1 here and then this 1. So this 1 is a bit is out of the MSB. So this is nothing but a carry. Now, so this is how like we add numbers in binary. I just wanted to show you how to add the binary numbers. So we just talk about that if we want to add two n-bit numbers, we need n plus 1 bit to store the result, and that means we need one extra flip-flop. There are like a flag register in which we have like various flags such as carry, overflow, zero, non-zero. We'll talk about all these flags later, but this 1 bit we will store in a carry flag. These 4 we can store in like accumulator. So accumulator is a register that is generally used to store the result, and this one we can store in the carry flag. Similarly, if we talk about the multiplication, if you want to multiply these two numbers, so let's see like just for an exercise how to multiply like two numbers in binary. So like in the decimal, how we multiply two numbers. Suppose we have to multiply 25 into 1 1. What we do is 1 is to 5, 1 is to 2, 1 is to 5, 1 is to 2. So as we have to multiply this 25 to 1, we write 25 then 25. Suppose we have one more 1, so we will write this 25 here, and then we add all these numbers. This is how we multiply in the decimal. Similarly, in the binary we do the same thing. We have to multiply this number 1111 to 1111, means we have to write this 1111 four times. One time for this one time for this, one time for this, one time for this, because here we multiply 25 to 3 ones, so that's how we write 25 three times. Similarly, we write this 1111 four times, and finally we add all these numbers. So Just for an like exercise, we will add this. So here we have this 1 here, then 1 plus 1 1 0. So 1 0 is there, so 0 we will take here, and 1 is carry, so this is the carry. Now we add 1 plus 1 1 0, plus 1 1 1, and then plus 1 1 0 0, because here 1 1 plus 1, so it is 3, it is 1, it will be 1 0 0, this is 4. So 100 is there, so we take this 0 here, and now 10 is carry. 10 is nothing but 2, so that's how 2 is carry here. Now 2 1 3 4 5 6, 6 is nothing but 1 1 0, so we take this 0 here, 0 here, and uh, 1 second, we take this 0 here. Now 1 1 is the carry, 1 1 is nothing but 3, right? So now 3 plus 1 4 5 6, again we will have 1 1 0 as 6, we will take this 0 here. Now again 3 is carry. Now 3 plus 1 4 plus 1 5, 5 is nothing but this 1 0 1. Now we take 1 here, and then 1 0 is carry, 1 0 is nothing but 2. Now 2 plus 1 3, 3 is nothing but 1 1, we have 1 this here, and this carry is here. So this is how we multiply the binary numbers. Now we can see that our input is 4-bit, but our output is 8 bits, right? Here 1 2 3 4 5 6 7 8, that means if we multiply two n-bit numbers, we need 2n bits to store the result. So here we have written that if we multiply two n-bit numbers, we need 2n bits, right? That means we need a register pair, means two registers of 4-bit each to report the result or store the result, right? Now we will solve this get question. Here consider the following multiplication. This 10w1z into 15 is equal to y010110001, and we can see these two numbers are in binary because the base is 2, but this 15 is in decimal because the base is 10. And what we need to find, what are the values of x, y, z? We need to find the values of this w, z, and this y. So first we need to like convert either these two to decimal, because this is already in decimal, or what we can do is we can convert this into binary, because we have two numbers already in binary. We will do the like second case, that is we will convert this 15 into the binary, and then we will try to multiply. So let's solve this. So we can rewrite this like 10w1z base 2 into 1111. So the binary of 15 is 1111, base 2 is equal to y010110012. Now everything is in the binary. So in this multiplication, we saw that if we want to multiply some number with like 1111, we just write this number that many times. So we want to multiply this number with 1111, that means we need to write this 4 times, and then we will add, right? So let's do this. So 10w1z, we write it 4 times, 10w1z, 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 and we will add this. After adding, the result is this. So it is 1 0 0 1 1 0 1 0 y, right? So this is how we represent this multiplication, and we have to find this w, y, and z. So here z should be equal to 1, because there is just one term, and after adding we are getting 1 here, means z is equal to 1. So if we write it in here, we directly found that z is equal to 1. So what we will do, we will replace we will replace all this z with 1, because we found that z is equal to 1. So we will just remove these z's and we will put 1 here. Okay, now we will add this. So 1 plus 1 is 1 0. We will take 0 here and we will take carry 1 here. So this is the carry. Now here 1 plus 1 1 0 plus 1 1 1. We are adding 3 ones here and we are getting 1 1, but the output is 0, right? If output is 0, but here output should be this number, that means if w is equal to 0, we will get 1 1 only, and this will be wrong because the sum is here 0. So that means w is definitely 1, because here if w is equal to 1, then we will have 1 plus 1 plus 1 plus 1, means 1 plus 1 1 0 plus 1 1 1 plus 1 1 0 0, and here we are getting this 0, means w is also 1 here, because if we put w is equal to 0, it will be uh, 1 plus 0 plus 1 plus 1, that means 1 1, but here this 1 should be here if w is equal to 0, but here we have this 0, that means w is 1 only. So 4 ones are there, so we have 4, like 1 0 0 1 0 0, we put this 0 here, and 2 is the carry. 1 0 is 2, so 2 is the carry, so here we have this 2. Now we know that w is equal to 1, so we can replace these 3 w's with 1. So let's replace this 1 1 and 1, right? Now we have this 2 as carry, so 2 plus 1 3 4 and 5. 5 means 1 0 1, we are taking this one here. Now again 2 is the carry. Now we have 2 plus 1 3 4 5, again 1 0 1 is 5, we are taking this one here, and now 2 is carry here. Now 2 plus 1 3, 3 plus 1 4, 4 is 1 0 0, we are taking this 0 here, and again 2 is the carry. Now 2 plus 1 3, 3 is 1 1, we are taking this 1 here and we are taking 1 as carry. Now 1 plus 1 is 1 0, here we have the 0, then the y should be 1, because we are getting sum as 1 0, so y should be 1, so y is also 1. So that's how we these types of questions, and this is the answer. The value of w, uh, y and z should be 1, right? Now we'll go next. So this is one note here, that carry flag is used to using the CPU to hold the range exceeding condition of unsigned data. So here when we were adding like two numbers, uh, they there was an like overflow, because the output was 30 and we cannot store 30 in 4-bit. So we use this carry flag to store this one. So carry flag is 1, that means there is an overflow, that means there is the range exceeding condition, right? So carry flag is used in the CPU to hold the range exceeding condition of unsigned data. Means if carry flag is 1, the range is getting exceeded. If it is 0, we can store the response in the same bit range. So this is the condition. Is there an extra bit out of MSB? That was the case in the addition example. If it is true, means it is set. If it is 1, then this is carry, and if it is false or reset or 0, then it is no carry. So here we have this. So this is the MSB, right? This is LSB, this is MSB, and we have this extra bit out of MSB. So that means carry is 1. Now let's solve a few problems. We are taking 4-bit computation. We are adding 6 plus 7 and it will get 13. So this is 6 in the binary, this is 7. So 1 0 1 0 1 is 1, then 1 1 0, again 1 is carry, 1 1 1 3, 1 is there, and 1 carry 1. So here we can see that there is no like bit out of the MSB, that is out of MSB we have 0, means nothing, means 0. So that means carry is equal to 0. Let's justify this. So we have this PSW, program status word, and we generally store the result in the accumulator. So accumulator value is this one, 1101, and in the flag register, in the carry flag, we have 0 because there is here there is an extra bit out of MSB. No, there is no extra bit out of MSB, so that's why carry is equal to 0, and the answer will be the carry flag and then the accumulator. So carry flag is 0 and then the accumulator 1101, that is 13. So here also we are getting 13. Let's talk about an example with the overflow. Let's add 8 plus 9, so output will be 17. This is the representation of 8, this is the 9, so 101, 000, and 00011 is 0. So 11 is 10. We are taking this 0 here, and 1 is the carry. So we have this extra bit out of MSB, means carry is equal to 1 out, right? So in the PSW we have accumulator. So this is a very important point, that in the accumulator we don't have all this number, because in the accumulator we just have this 0001. One is stored in the carry, and the answer will be this carry and then the accumulator. So if you put carry, that is 1, in front of this accumulator, it will be 17. That is the correct. So that's all for this video. Thank you so much.